In this video, we'll demonstrate how to secure your Web API endpoints with tokens. We'll start by creating a new .NET Web API project. And for this demonstration, we'll be using the long-term support .NET 8 version. We will be using Swagger in conjunction with the Endpoint Explorer, so we need OpenAI support, and we'll use controllers, but we will also mention how to use authorization in minimal APIs. Once created, you can remove the generated weather forecast and weather forecast controller classes. First to do is to install some NuGet packages to work with our database and identities. Right-click your project and go to Package Manager. We'll need the Microsoft.ASP.NET Core.Identity.Entity Framework Core as our ORM. Make sure to select a version that is compatible with the .NET framework you're using. We'll be using SQL Server for our example, but you can install for whichever supported database you need. Again, make sure you select the correct version. The last entity framework package we need is the design package. This is needed for database migrations and updates. All three of these packages should have the same version number. To set up our database, we first need a data context class. Here we added a folder called Data and added a class called AppDBContext. This class must inherit from Identity DB context instead of the standard DB context, and it uses the identity user model. In the constructor, we set an options parameter and invoke the base class. In the app settings file, we added a connection string called default connection. We'll be using our local database server and call the database secure API DB. You'll have to set up your connection string in accordance to your specific environment. Before we create the identity migration for the database, let's add some services in the program.cs file. Just after creating the builder, add the DB context service and set the options to the database you're using. Here, we can retrieve the connection string from the app settings file. Then we need the authorization service and add all the identity API endpoints. After the builder has built, you can map to the identity API. With all that in place, build your application and make sure there's no errors. Now we can create the identity migration and update the database. You can use the command line for this if you prefer, but since we're already in the IDE, we might as well use the available tools. Right-click on Connected Services in your project and select Manage Connected Services. Click on the ellipses next to your database server and select Add Migration. Visual Studio will find your DB context in your project, and you can call your first migration something like Initial. Click Next, and your migration will be created. This migration will add a whole bunch of identity-related tables to our database. Back to Manage Connected Services again, and we can now update our database with the migration. Visual Studio will find your DB context again and update your database. Let's see what happened in the database. Go to your Database Explorer, or in our case, we can select SQL Server Object Explorer from the View menu. Under the database's tables, you'll see all the new ASP.NET user and role tables that were added. The database and services are in place so we can run and test our API. Swagger will show us all the identity endpoints that were added. Let's try to log in. For the parameters, we just need to set the email and password. When we execute this, of course, we'll get a 401 response, which means unauthorized access. We need to register a user first. So go to the register endpoint and give it an email and password. If there's something wrong with the password validation, you'll get a 400 response. If you parse the JSON response, you'll get details about the error, such as password is too short, password requires a non-alphanumeric character, password requires a digit, or password requires a lowercase letter. If everything's valid, you'll get a 200 OK response. Back in our database, when you view the data in the ASP.NET Users table, you'll see the newly registered user. Now, when we try the login endpoint again with the registered email and password, we get a 200 OK response. The JSON response contains some important information for us. First, it tells us this is a bearer token type, and it gives us the access token. You'll need this when you're going to access authorized endpoints in your API. There's also an expiration time in seconds and a refresh token. Let's see how to implement our authentication in a controller. First, we'll add a simple model or entity that represents a player on a team. It has an ID, a player name, and a team name. Next, we can right-click the Controllers folder and add a controller. Select an empty API controller and call it something like Players Controller. We'll add a single get endpoint to retrieve a list of players. Here, we see the IntelliSense, or AI, already kicking in and creating the endpoint for us. But we want to do this manually to show how players are randomly generated as we add them. Then we'll simply return the players list with an OK response. When we run this, we see the new player endpoint in Swagger. At this point, there's no access control, and it simply returns the list of players. To prevent access to a specific endpoint in a controller, you can simply decorate it with the Authorize attribute. Alternatively, you can control authorized access to all the endpoints in a controller by decorating the controller with the Authorize attribute. Similarly, if you're using a minimal API, you can add .require authorization to an endpoint to prevent unauthorized access. Now, when we try to access this endpoint, it will return 401 unauthorized access. Not only are we not logged in, but we're not calling our API endpoint with our access bearer token. To demonstrate how this works, we'll use the Endpoint Explorer in Visual Studio. You can quickly test your API endpoints by double-clicking the .http file in the root of your project. Here you can create HTTP requests and send them to your API. Alternatively, you can open the Endpoint Explorer through the View Other Windows menu. The Endpoint Explorer will give you a list of all the endpoints in your API. To create a HTTP request for a specific endpoint, right-click the endpoint and select Generate Request. Click on Send, and a results window will open with the request response. As you see, the Get All Players endpoint still returns 401 unauthorized. Let's quickly log in using Swagger. We give it the email and password of the user we already registered. Once logged in, we need to copy the access token provided for us. Back in the Endpoint Explorer, we change our HTTP GET request and add the keyword authorization, followed by a colon, then the token type, which is bearer, and then the provided access token. Now, when we try send again, the API recognizes the authorized token, and we get an OK response and a list of players. We can pass the access token into Swagger without using something like our Endpoint Explorer. To do this, we need to tell Swagger to add a header parameter to our requests. In the program.cs file, find the add swagger gen statement and add an options parameter. Add a security definition to the options and pass it a name and an open API security scheme. Essentially, we're going to add a parameter to the header of our HTTP requests. The in parameter specifies where this parameter will be located. Here we say it will be in the header of the request. The name of the parameter will be Authorization, the same as what we used in the Endpoint Explorer, and the parameter will hold an API key type. To get the header parameter to work, we set the operation filter to Security Requirements Operation Filter, as we do here in line 34. You may have to install the latest swashbuckle ASP.NET Core filter package. Now, when we run our app, we get an Authorize button at the top of Swagger. We'll use this to pass our bearer token to Swagger. Of course, to get an access token, we first need to log in with our registered user. Copy this token without the quotes. Click on Authorize at the top, and in the value of the header parameter, type bearer followed by a space and paste the token. Click on Authorize. Now you can access the endpoints, which requires authorization. If we were to click on Authorize again and log out, we'll no longer have access. Notice how the header parameter was added to our request. It's the same as the parameter we added when we used the Endpoint Explorer. It's important to note that the bearer tokens we've demonstrated here are proprietary to .NET Core. They are not standard JSON Web Tokens. These are part of the Identity API and are not intended to be a full-featured token service, but instead provides an alternative for users that cannot use cookies. JSON Web Tokens, on the other hand, can provide a single sign-on ability to multiple applications and are not specific or proprietary to your own application. JWTs are usually generated and validated by some middleware token service. Alternatively, if you don't require JWT features, it is recommended that you use cookies. This is still a valid and secure authentication method that is implemented through the browser. Let's demonstrate how cookies work. We'll refresh and make sure we are not logged in. Under the login endpoint, we set the use cookies parameter to true and enter the credentials of our registered user. When we log in, it will set use cookies to true in our request, and it no longer returns a bearer token. The user's authentication is now tracked by a cookie in the browser. Let's test this with the player's endpoint. Notice there's no more bearer token in the request header. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.